This cube sold for $250,000, I believe.
Oh, maybe that's an industry we can branch out into.
Right, Jan-Philippe, thank you for joining us. You work for Dunlee, that's right, isn't it?
Yeah, that's correct.
And what do you do at Dunlee?
So at Dunlee, I'm the business manager for the 3D printing business. It's quite a new business within the Dunlee construct, where it comes from a traditional manufacturing background, and 3D printing started around 10 years ago, and it really kicked off in the last 5 years.
Mm-hmm. And you say 3D printing, but obviously we both know that's quite a wide area. Mm-hmm. What exactly are you doing at Dunlee? 'Cause it's pretty interesting.
So we create anti-scatter grids. So I'm holding an enlarged version in my hand here. So for the audience to visually understand what kind of products we're creating. So what we do is we 3D print anti-scatter grids, and then we post-process them so that we can use them in a CT system, so in a computer tomography medical system. And what it does, it's very basic. It has a basic function. What it does is absorb any unwanted scattered radiation, so that at the end you have a clear image coming out of the CT system, which allows the patients or the doctors to come to a quicker diagnosis, and patients to face less rescanning.
Right, okay, which again, that minimizes the radiation they're exposed to.
Exactly.
Yes. Mm-hmm. And is this the type of scatter grid that goes into the system? This isn't the full size, is it?
No, it's much smaller. So
yes.
What I can do is I can quickly change to another component. So this is around the size we're looking at. This is quite a long version, but that's the kind of size you're looking at. The features here are 100 micron walls, so that's what we pride ourselves on. Products with 100 micron walls with 25 micron positional accuracy. So, and this with pure tungsten. Mm-hmm. So that's no easy feat. So this is something that we've been developing over the past 10 years, and it's really, as I mentioned, kicked off in the last 5 years.
So can I have a look at that?
Yeah, please. Try to look through it. So what you'll also notice is that the pixels, they're all focused. So you can see through some of them, but you cannot see through all of them. And we do this because the X-ray emitting source, all holes should be focused towards it so that they don't absorb the X-rays that create the image at the end.
Well, I mean, tungsten, this is quite heavy for its size. This is, mm-hmm. And it's one of those metals you don't see very often. Why is that?
So tungsten is quite difficult to harness for additive manufacturing or for manufacturing generally. But tungsten in the CT application is perfect because of its density. So as you mentioned, it's quite heavy. And this weight is actually what makes it dense, and the density is what makes it perfect for radiation absorption.
So would it be possible to make this by any other methods?
Very difficult. Mm-hmm. Meeting the spec requirements will be very, very difficult. So there's an economic reason behind it why we do it with AM. And what it also allows is more freedom of design. So what our customers are able to do, they're able to create anti-scatter grids according to their detector, how they want to build that. So it's giving them freedom in other areas as well.
And what's the, what sort of challenges of working with a material like tungsten, which, as you said, is a very dense material?
So, well, one challenge is, of course, on the printing side. So we're using printers from EOS, and their printers, of course, their chamber is built for a certain weight limit. So we cannot fill our chamber fully with powder, so that's quite a challenge. But other than that, we have other challenges in terms of post-processing. But unfortunately, I cannot go more into that because that's part of our secret recipe.
I understand. So, I mean, this is, it's quite a remarkable part, and actually you can tell the precision just by looking through it, because it really does change what you're seeing through there quite dramatically. So we have to get a close-up of this at some point. What's next, though, for Dunlee? What's next? What have you got planned?
So, anti-scatter grid business is what we started with. We've grown it to mass production now, so we have a machine park running 24/7, and we're printing hundreds of thousands of these products a year. But now we're trying to branch out. We're looking into new business development, so looking at new industries as well, but also adjacent industries such as cargo scanning, luggage scanning, but new industries such as nuclear fusion. We're looking at industries such as aerospace, so satellite applications. So it's the world is our oyster at the moment.
Yes.
So we're really looking exploratively. It's all still in the R&D phase, so it's very exciting stuff.
And how about shows like Formnext? What's it like coming back to probably the world's biggest 3D printing show at the world's second largest trade show venue?
It's great to be back here. So we've been here a few times already. The last time 2 years ago, I think, like everyone else. So for us, it's a great opportunity here to connect with all the different players in the market. So the whole chain. And that's also what we're doing here. We're not just meeting with potential customers, but we're also meeting with the rest of the community, seeing what they're doing, what advancements they've made, and for us also seeing what other opportunities there are in terms of our value chain.
And what trends do you see in the additive manufacturing world?
So I see quite a few interesting things. So I see sustainability being more and more of a topic. So as production or mass production is becoming more of a norm, I see a lot of companies putting their focus on sustainability. So for example, EOS with their new polymer system that they're saying is net neutral. That's really cool stuff. But we also see a lot of companies combining forces. So Brainport, for example, combining forces with different companies within the Eindhoven area, and all coming together here on one booth. I think that's fantastic, giving companies the space to show themselves here. In the past, they weren't able to, or they were never here at the show.
And it really is collaboration and having these groups of companies where the ideas really start to take off often.
Yeah, exactly. And that's the whole point. We want everyone at the table so we can all see and discuss and really help each other.
Thank you very much for your time.
Thanks a lot, Michael.
I have to ask, because I'm holding here this rectangular piece of tungsten.
Yep.
Are you aware of a cuboid piece of tungsten that was made for sale as an NFT? And purchase of an NFT gives you the right to go and lift up this or touch this cuboid piece of tungsten once a year.
Oh, no, I wasn't aware of this.
It's a big meme, apparently.
Okay.
In the crypto and NFT world.
Oh, okay, yeah.
But, how much would it cost to make a cube with a dimension, say, each side this long?
Oof, that's difficult to say. So we're not in the business of making cubes, so that's difficult for me to say. But yeah, from an anti-scatter grid perspective, what you're holding in your hands, you're looking at something around 3 digits.
Right.
So but it's all design specific, what the customer wants, how many walls, how focused, and what the specs are at the end of the day.
It may be worth doing. This cube sold for $250,000, I believe.
Oh, maybe that's an industry we can branch out into.